Hello everyone. So today we're going to be streaming about properties declaration in classes. So if you haven't already, please subscribe to the channel if you enjoy the content on Kotlin. We're talking about Kotlin 2, so I hope you like these videos. I think Kotlin will gain more and more um yeah, like it will gain more um I don't get the word. It will it will become much more popular in the future. That's what I wanted to say. Because I think it's a valid um replacement, or it has many advantages with respect to Flutter programming, since it's based on the previously very popular Java. So I think you guys, if you know Flutter and Dart, you have to learn about Kotlin as well. I believe that it will make you more of a complete developer. So let's start with the properties, in particular with the declaring properties. Properties in Kotlin classes can be declared either as mutable using var keyword, or as read-only using the val keyword. So the var here means that this property can be changed, and the val means that it's read-only, so it is immutable. I don't remember if I have started Fleet. Let's go with this one. And if it's up to date, I hope so. Yes, it is. Good. So we can use Fleet. To use a property, simply refer to it by its name. And for example, in here we are going to, yeah, here it copies an address from one address to another one. So we can use this same example just for the purpose of learning something new. I would put it inside the example folder address. And now we're going, yeah, we also need to create another lesson, as we usually do. So lesson will be lesson 12. And we're going to say play with properties. And then we're going to create it. I don't remember where we usually create them. Let's see. So where is it from? It's in site classes. So yeah, I think we can create it here. And we can say function play with properties. And then we're going to import this function, and then we're commenting this 11th lesson. So now we have our playground ready, and we will create a class with address, which has all these properties. And I'm going to create the address class here, address.kt. And now let's create this class. And I don't want to give the strings a default value, so I will delete them all. Okay, working. So let's do it by line by line. Should be easier. Now it's also complaining about something. Let's see what. But yeah, it needs an initializer. So since these properties are not inside the constructor, they pass the IDE and Kotlin requires them to be initialized. If I place them inside the constructor, then I don't need to initialize them. And that's what I prefer to do. So let's call address one. And let's call this address from our class. Now let me generate a couple of examples with this class. I will ask ChatGPT. So if you want to, we can do it together. Let me hide this, and I will move to a new tab. New window, sorry. So here we go. Generate an example. Yeah, like 3 examples of this class instance. So of an object instance of this class. All right, so it's telling me we have 3 random addresses here, and let's place them over here directly. So, all right, what we are going to do now is we can say, as they're doing in the Kotlin documentation, we can copy one address like name and street to another address. Let's try and do this by saying address 3. So first of all, sorry, let's print them all. So print line. So I would declare these as data classes just to have the printing the toString option, the toString method properly implemented. So address 3 right here, and now let's run this first to see the addresses. It's a little bit slow. All right, there we go. So we have the addresses, and what we might do now is first, and then I will copy them, and I will assign to address number 3 the city of address number 1. So that's what you could do with variables if you have variables here. We had already seen that if you declare them as values, you cannot change them anymore. And for example, let's say that the state and cannot be changed. So if I try to say address 3.state, then it will complain that state is not reassignable, so it cannot be changed, and it needs to be a variable in order to do so. And so if I accept the difference, it will make me able to change it. If I run this, of course, the city will change inside address number 3. So let's maybe put a new line here, and let's run again. So as you see, address number 3 has the same city as address number 1. Just a second. Okay, I think okay, now let's go on with what we have in the documentation. We have getters and setters. The full syntax for declaring a property is as follows: variable, property name, as we have seen, property type. So we have variable, property name, property type, and then we have property initializer. So if you want, you can assign a default value like test, and then you can use setter and getters. We'll see what these are in a second. So the initializer, getter, and setter are optional. The property type is optional if it can be inferred from the initializer or the getter's return type as shown below. So if you say boolean, sorry, variable initialized 1, then this property will infer the type integer from the initializer, which is 1. And it will have default getter and setter, it says. But however, if you try to have a variable like test, then it will say if the property must be initialized or it must be abstract. But I think even if you say it's abstract, it has to have a type, be initialized, or be delegated. All right. So if you let's try to delegate it, but I think you still need to, yeah, you would need to specify a type like variable integer, and then it will also say that you must initialize it or declare it as abstract. So if I declare it as abstract, then it will be probably okay. Abstract property is not abstract class. Yeah, it's not in an abstract class, so we need to make an abstract data class and so on, or an abstract class actually. So let's go on. The full syntax of read-only property declaration differs from a mutable one in two ways. It starts with value instead of variable and does not allow a setter. So as you have seen, it is value simple in it int, sorry, nullable int, has a type integer, default getter, and must be initialized in the constructor. So if you declare a value like simple and say this is an integer, it needs to be initialized. So what we could do is init create an initializer where we say that simple is equal to something like 3. It will say that it can be joined in an assignment, but actually this is useful if you check like some properties like zip and say if above 100, then assign simple to 3, else assign simple to something else like 5. So let's do something like, okay, the zip is a string in this case, but let's say that we have it as integer to int or null. And what else? We say that this has a value 0 otherwise, and we say above, we rename this to something that make more sense, like above 100, above 100. And here we say instead of that, we say true and false. So we're checking if value is above or below 100, and we can use all the suggestions here to calculate it in a more clear way. Okay, so you can define custom accessor for a property. If you define a custom getter, it will be called every time you access the property. This way you can implement a computed property. Here's an example of a custom getter. So we have seen this rectangle already. Let me see the rectangle if I find it somewhere in the code. Yeah, it's over here. So let's compute the area. So we have all of this. What we can do, as you see here, is we can say that the area is an integer property, and each time we call dot area, this function will be computed. So what's the advantage here? That if you change the height and width, there's some issue, then it will compute again the area even after initialization. So you have to bear this in your mind. I want to show this, what I mean to you. So let's try and create a rectangle. Val rectangle equals rectangle, and let's have 3 and 5, and then rectangle dot area, and this will be 3 times 5. So let's do this. Then what else? I want to create a toString method. So override toString function, and let's say this is a rectangle. Okay, so it's okay like this. Rectangle toString here. And okay, I'm missing something. Yeah, rectangle area. And let's run this. So as you see, rectangle, rectangle with area 15. Great. So let's do something else next. So we have rectangle area 3 by 5, but what I wanted to show you is what happens if I say this is a variable. All right, sorry. Yeah, here we have to change variable in order to compile, but this is just for now. What I want to show you is that the area will be recomputed if I change the width or the height of rectangle. So for example, let's put like 10 as a width, and let's print this again. You will see that area is recomputed and it will have a different value. All right, sorry for the bad printing. Let's copy this and let's put it here. So now we have an area of 30. But what happens if I calculate the area in a different way, like what I'm showing you now? Area bad. Let's see what kind of value we have, and then let's analyze what's happening here. All right, so as you see, instead of having 30 as an area in the second value that I calculated, I'm having 15. That's why is this happening? Because I'm passing something to rectangle like the height and the width, and the area bed is calculated against the non-final property, which is passed as arguments to rectangle, and it will store this result, and this result will not change even though we're changing the height and the width. So this property is not recalculated each time I am going to access this value. Instead, with the area and with the getter, this value is recomputed each time I'm trying to access this value. So that's the main difference, and you have to be aware of this because it's a very useful feature of Kotlin. And this is very similar to what you would have with a function, because each time you say like function calculate area, and you say this width times this height, the result will be the same as area. So there's nothing strange here. It's very similar to what you would have with Java, and you will get 30 as a value, but this syntax here is more concise, and it's better also because it's a value of the rectangle class. All right, so let's go next. You can omit a type if you want it to be inferred from the property type. Yeah, from the result. If you define a custom setter, it will be called every time you assign a value to the property except its initialization. A custom setter looks like the following. So yeah, string representation, this to string, and set value, set data from string value. Okay, I think this is a little bit of a strange example, and it's not very easy to find a good example here, I think. But maybe what we could do is say, what can a rectangle have? Like a text inside it. So, well, text inside, and then this will be a string, and it will have a getter. Yeah, maybe we could say the getter gives this as a value, as a string, and then we have setter, which is something like set value, and then we do something like with this value. So what they're doing is set data from a string. Okay. A val cannot have a setter. So let me, yeah, because we have a value here. So yeah, it needs to be a variable to have a setter. Otherwise, we cannot have a setter, because that's normal. Okay, because the value is immutable. And here, what we can say is print line new value is value, right? And let's see, do we have to return something? I don't think so. Yeah, as you see, unit was expected, so the set is actually a unit. Probably if we do this dot value, yeah, maybe you can access other properties as you see here, like calculate area. You could do something like this. I don't know if it could be useful for you or something. What else you could do is say, okay, this dot text inside equals to value. So let me see, convert this to why does it want me to recursive property accessor? Probably let's see, text inside. So let's run this. I'm not even sure. I want to be sure about the results. So text inside is not called anywhere. So let's call it here. Rectangle text inside. Okay, drawing a rectangle 3 by 10, and this is what it's calling the get. And then we want to change the text inside to something like hello. And let's run this. Okay, it is saying new value is hello, drawing a rectangle 3 by 10. So it's basically, yeah, accessing this again. And let's try and print it again. So rectangle text inside. So as you see, the value has not changed because we have altered the set. So the set is now only printing something. So this is the old value and this is the new value. And if I want to change the old value, I think I need to do this, which was, yeah, field equals to value. That's what it's saying. And initializing, okay. So if I do this, he wants me to initialize it. So let's see what the syntax was. Equals to something, and this way it will not complain anymore. So let's run this again. Maybe what we could do is say also null. So this way we don't give it actually a value. Now let's run this again. Okay. So new value is hello and old one is drawing a rectangle 3 by 10. And when we call the get, we still have drawing a rectangle 3 by 10 because we have not actually changed the text inside value. So Yeah, we're not printing the text inside value, so that's the issue that we have. We're basically hiding it. And let me try like this. So now we should have text inside the field. First time it will be null, and then we'll have some value. Let's try. Yeah. So drawing a rectangle 3 by 10, and then we have text inside, which is null at first because the field is null. And then when we call the set, so we set text inside, like we're doing over here, then the text inside will be hello, and new value is hello, old is this one, and then we can say draw a rectangle 3 by 10, and then hello will be the text inside will change. So that's what we're doing with this getter and this setter. All right, by convention, the name of the setter parameter is value, but you can choose a different name if you prefer. So by default, yeah, we're using this, but we can say something else. And you have to use the field to specify that you want to change text inside here. And if you want to access the value inside the getter, then you can do it with field still. If you need to annotate an accessor or change its visibility, but you don't want to change the default implementation, you can define the accessor without defining its body. So, for example, this might be useful if you want to have a private set, but you want this to be a variable. So yeah, you want it to be mutable, but you want to change it only inside the class and not outside. So, for example, let's say this is a private set. As you see here, it cannot be used anymore because it's private. And what we can say is function new text inside, and then you could say text inside equals new text inside, and then you could assign it this way, and then this should be a string, of course, and then you could say you could call this and as a string, and the result will be the same. All right. You can also annotate a setter with inject. All right. So this might be a topic for injection, which we will see in later episodes. Backing fields. In Kotlin, a field is usually used as a part of a property to hold its value in memory. A field, yes, so it's used as a part of a property to hold its value in memory. Fields cannot be declared directly. However, when a property needs a backing field, Kotlin provides it automatically. This backing field can be referenced in the accessors using the field identifier. So that's what we have already used. We're using the field So we are inside the accessor, which is this part of the code, and we're using the field identifier, which is a backing field. The field identifier can only be used in the accessors of the properties. So yeah, if I use it outside, I cannot do this. A backing field will be generated for properties if it uses the default implementation of at least one of the accessors, or if a custom accessor references it through the field identifier. Okay. For example, there would be no backing field in the following case. So yeah, if for example, in this case, you might not use the backing field. If you need it, you can. If you don't need it, you can omit it. All right. So in this case, with the area, we were omitting the backing field. We did not need to use it. If you don't want to do something that does not fit into this implicit backing field scheme, you can always have a fallback to having a backing property. So yeah, they're using a backing property, as you see here. So if table is null, table hash map creates a hash map, and it returns this table. And yeah, so if someone tries to set this as null, then it will throw an error. But yeah, indeed, I don't think this is a nice example. Compile time constants. If the value of a read-only property is known at compile time, mark it as a compile time constant using the const modifier. Such property needs to fulfill the following requirements. It must be a top-level property or a member of an object declaration or a companion object. It must be initialized with a value of type string or primitive. It cannot be a custom getter. The compile with will inline usage of the constants, replacing the reference to the constant with its actual value. However, the field will not be removed and therefore can be interacted using refactions. Such properties can also be used in annotations. Okay, so let's try and do all of this. So like units, maybe we say const val unit is 1. As you see, I am not allowed to use it on a top level. I have to create and move it to a companion object, which is usually at the end of the code of the class. So constant value is equal to 1. And what I could do is I could say this is deprecated. And I could say this function is deprecated view.area valid. All right. Yeah. So replace with dot area. Didn't know this existed. So if I try and see it here, yeah, it will say it is deprecated. Nice. And yeah, I could say this is not does not mean anything, but I could use the unit here. And actually, since this is a constant, I actually need to use it like this. Or maybe to make more sense, what we could do is this. Deprecation text. Right. So we have our deprecation text and we have our replace with suggestion. Replace with dot area. Perfect. So I'm doing these live streams so that we all have basics in Kotlin, and then we can go on with multi-platform projects and other funny stuff that might be more interesting. But this will be the hardest part to follow this all this course from the start to the end, but it will be very useful for the things that we will do later. So yeah, we are almost at the end here. Late initialize properties and variables. Normally, properties declared as having a nullable type must be initialized in the constructor. However, it is often the case that doing so is not convenient. So, for example, properties can be initialized through dependency injection or in the setup method of a unit test. So inside a unit test, in these cases, you cannot supply a non-nullable initializer in the constructor, but you still want to avoid null checks when referring to the property inside of a body class. So the cases that they're seeing here is when properties can be initialized through dependency injection or in the setup method of a unit test. Okay, so let's keep this in mind. Let's get back to our address now. And let's make a variable. Maybe we call it, as they're doing here, subject string. It will complain. You cannot, yeah, you have to initialize it, or you have to add a late init operator. And what this will do is it will allow us to handle the cases which we don't want this value to be null, or we don't want this value to have an initializer. So what's the advantage of doing this? That yeah, I don't need to specify the initializer, and I can still use this later if I initialize this, of course. So examples. When is it useful? If I have to do dependency injection, or I am using it in the setup method of a unit test. So this example shows public class my test, and in this example, they're using a setup function and a test function. So yeah, maybe it's better to create a test. We could do it test address of PT. So let's do a test on address. Maybe it will be more clear. So I copy all of these. This is my public class, my test address, and here we will say address. So we have the address, and we say test address here. And okay, the annotation setup and test are not present, so we'll remove them. And we have our address here. It will be created with some values. We'll just copy what we have here. And now what I want to do is, let's say address dot yeah, zip address.zip. Yeah, let's do assert that address is above 100. So since the zip code, was it the zip code? Yep, the zip code is above 100, then this should be true. So now let me check something. Yeah, we could remove this. All right, so now it will just check if this is true or not. And what we can do is create a class test address inside our lessons. We do properties over here, about test address. And let's call this test address. And now let's test address dot setup and then test address dot test. And let's run this. Am I forgetting something? Yeah, because I'm not printing anything. So the assertion is true and we're not getting any exception. So that's good. So the test runs well. Right. We could say PoliMi test. Okay. The modifier can be used on var property declared inside the body of a class. Not in the primary constructor and only when the property does not have a custom getter or setter, as well as for top-level properties and local variables. The type of the property or variable must be non-nullable, and it must be not a primitive type. Okay. Accessing a late init property before it has been initialized throws a special exception that clearly identifies the property being accessed and the fact that it hasn't been initialized. So you can check whether a late init var has already been initialized. You can use the dot is initialized on the reference to that property. So the reference will be use property reference to access property reference of first class object in Kotlin. You have to use this type of operator. So let's do this inside here. So before doing that, let's call address above 100 is initialized. So this will check if this is initialized. This declaration can only be called on reference to a late init property. Okay, why is it complaining? Since it's a late init property. I don't know, maybe it's something wrong with the ID. Let's check. Oh, it's complaining here. Maybe I need parentheses. I don't know. What am I doing wrong? I've already used this syntax, so I'm pretty sure that it works. What is going on here? Maybe. Maybe. Oh, that's pretty strange. Let me check. Check if property is initialized in Kotlin. What am I doing wrong? Check here. This, maybe. This value, yeah, it's public. So, what's happening here? Let me try and do it around this like this. So let me say address. Oh gosh. Ah, the late init is address actually. So sorry guys. So the address is this. It's not above 100. I thought, I don't know, I was mistaken. I thought above 100 was the late init power, but it's actually the address in our case. Okay, sorry. So now it should run good. Yep, it does. That's okay. And I want to show you something. If I comment this and yeah, I say a refactor, nope. All right, let's do like this. If I run this, it will throw an exception saying that late init property address has not been initialized, so we cannot. Yeah, it actually throws an exception here. And same if I remove the assertion. So the assertion is actually not even needed in this case. Right? So that's why it's useful to have this late init in case of tests. That's great. Let's go on. Properties. Okay, overriding properties. We had already seen that you need to use open classes if you want to override the values, and that the values you want to override need to be open as well. Then you have delegate properties. The most common kind of properties simply reads from and maybe writes to a vacuum field. But custom getters and setters allow you to use properties so one can implement any sort of behavior of a property. Somewhat in between the simplicity of the first kind and variety of the second, there are common patterns for what properties can do. A few examples are lazy values, reading from a map by a given key, accessing a database, notifying a listener on access. Okay, such common behaviors can be implemented as libraries using delegate properties. Okay, so we'll see the delegate properties later on inside our course. And I think we can go quickly to interfaces now. And instead of saying play with classes, we could do, where is that? Where is our example here? So let's say play with interfaces, create a function. Yeah, we could say I want to create it here, interface interface.kt, and now so interfaces can contain declarations of abstract methods as well as method implementation. What makes them different from abstract classes is that interfaces cannot store state, okay? They can have properties, but they need to be abstract or provide accessor implementations. So yeah, as you see, you could say that a function has an optional body, and you can say that you need to define the body yourself if you want to implement this interface. So let's create my interface, and let's say this is bar, and this is full. So you can have a default, let's say, empty body. Implementing interfaces. A class can implement one or more interfaces, okay? So let's call these. Yeah, this doesn't make a lot of sense. Maybe let's do this. Let's see if rectangle. Yeah, rectangle would have had the interface iRectangle. And we're going to implement it and its members, right? So the member is bar and the member is full. But as you have seen here, you don't need to implement full, even though you can, all right? All right, and you might also decide to change these, okay? And you can do that. Properties in interfaces. So you can declare properties in interfaces. A property declared in an interface can either be abstract or provide implementation for accessors. That's very interesting. So properties declared in interfaces can't have backing fields, and therefore accessors declared in interface can't have them. So what we could do with this interface is something like this. We could move height and width and area to the interface. So let's try and do this. Let's say this is a value of width, integer, and value of height, integer. Now, yeah, sorry, they cannot be in the constructor, they have to be here. And now it would say override. So we kindly override, and we don't need to have them as open now. That's also interesting. What else could we do with this? We could say take all these functions that we have here, like area bed, and calculate them directly inside the interface. So as you see, in this case, we cannot do this with area bed because area bed width and height need to be initialized before the usage. And this is also the reason why the area bed will be only referred to the initial values. But however, we could use a function here. Like the area and calculate area can be moved inside the interface directly. I don't think that the string could be moved also because we are overriding it. So we have to leave this one here. Let's see if the companion object can be moved. Yes, it can. But if we reference it from here, we have to import it. Okay, so that's pretty interesting, I think. I hope you get the point of this. So now if you create like a rectangle, all right, play with interfaces. I think we don't need it for the moment. Run. Okay, so it's running as before with all the same results, so we're pretty happy about it. Okay, so we have seen these interfaces inheritance. So an interface can derive from other interfaces, meaning it can both provide implementation for their members and declare new functions and properties. Quite naturally, classes implementing such an interface are only required to define the missing implementations. Okay, so we have, in this case, we have a person which comes with a first name and last name, but it also inherits from name, and this is doable. So yeah, if you, of course, if you have a name, you need to override it in order to declare it as first name and last name, as they're doing in this example. And then, as you see here, data class employee will inherit from person. So we have seen this already, I think. When you declare many types in your supertype list, you may inherit more than one implementation of the same method. So we have A, B, and we have C that inherits from A, we have D that inherits from A and B. And you can use the supertypes just by defining the type of interface you want to run this from. So that's also possible if you want to do so. So I think that for today it's all. We have seen how properties work and backing fields and backing properties, and we have seen how interfaces work, and we have seen one interesting thing that you can declare getters and of properties and some functions if you of course use the properties of the interfaces inside the interface directly, and this was not possible, I think, in Java, but correct me if I'm wrong. Thank you very much for watching. Subscribe if you like this type of content, and let's see you on the next video. Thank you, guys.